A single mistake on a construction site can change a life forever, and many site safety training exam candidates lose easy points because they misunderstand the basic OSHA safety principles. Before you step onto a job site or sit for your SST certification exam, you need to know the rules that protect workers, prevent accidents, and keep projects running safely. Stay with me until the end of this complete study guide because we will cover all 6 exam sections in a simple, step-by-step format. You'll also find a free SST study guide with the most important practice questions linked in the description to help you review everything after the lesson. Welcome to Section 1 of your complete Site Safety Training Exam Prep course. In this section, we will build the strong foundation every successful SST candidate needs. You will learn the essential OSHA safety standards, understand why these rules exist, and see how they apply to real construction sites and exam scenarios. These concepts are not only critical for passing your certification exam, but they can also help prevent injuries and save lives on the job. By the end of this section, you will have a solid understanding of the core safety principles that appear throughout the rest of the course. So, let's get started and begin building your confidence for exam day. The Occupational Safety and Health Administration, commonly known as OSHA, is the federal agency responsible for regulating workplace safety in the United States. Congress created this agency to ensure that working men and women have safe and healthy working conditions. You will frequently see exam questions asking about the primary purpose of OSHA, and the answer is always about setting and enforcing standards to protect workers. Every employer has specific legal responsibilities under OSHA regulations, starting with the General Duty Clause. This clause states that employers must provide a workplace that is free from recognized hazards that are causing or are likely to cause death or serious physical harm. Even if a specific OSHA standard does not explicitly cover a dangerous situation, the employer is still legally required to fix it under this general rule. As a construction worker, you have specific rights protected by federal law that you need to know for your exam. You have the right to receive safety training in a language and vocabulary you can easily understand. You also have the right to review records of work-related injuries, access your medical records, and request an OSHA inspection if you believe your site is unsafe. When OSHA compliance officers visit a construction site, they follow a specific priority list for their inspections. The highest priority is always given to situations of imminent danger, where there is a reasonable certainty that a hazard will cause death or serious physical harm immediately. Fatalities and severe injuries are the second priority, followed by worker complaints and planned targeted inspections. If an employer violates safety rules, OSHA can issue citations and financial penalties. The most severe type of violation is a willful violation, which happens when an employer knowingly fails to comply with a legal requirement or acts with plain indifference to employee safety. Willful violations carry the highest financial penalties and are a common topic on the certification exam. A very important concept for your exam is whistleblower protection under Section 11C of the OSHA Act. This law strictly prohibits employers from firing, demoting, transferring, or otherwise retaliating against a worker who complains to OSHA about unsafe site conditions. If a worker is punished for reporting a safety hazard, they have exactly 30 days to file a retaliation complaint with OSHA. The construction industry faces unique dangers, and OSHA has identified 4 leading causes of worker deaths known as the Focus 4 hazards. These 4 deadly categories are falls, struck by hazards, caught in or between hazards, and electrocutions. The exam will heavily test your ability to identify which category a specific accident belongs to, so we will look at each one closely. Falls are consistently the number 1 cause of fatalities in the construction industry. A fall hazard exists anytime a worker is exposed to a drop of 6 feet or more to a lower level. While we will dedicate an entire future lesson to fall protection, you must remember that the 6-foot rule is the magic number for requiring fall protection on standard construction sites. Struck by hazards occur when a worker is hit by a vehicle, a falling object, or flying debris. A common example on a job site is a worker being struck by a dump truck backing up without a spotter. The best defense against these hazards includes wearing high-visibility reflective clothing, securing tools when working at heights, and never standing under suspended loads. Caught in or between hazards happen when a worker is squeezed, crushed, pinched, or compressed between 2 or more objects. This frequently occurs when trenches collapse on workers or when someone gets pulled into the moving parts of heavy machinery. To avoid these traps, workers must never place their bodies between moving equipment and an immovable structure like a brick wall. Electrocution is the final focus for hazard and involves fatal contact with electrical currents. On construction sites, this often happens when metal ladders touch overhead power lines, or when workers use power tools with damaged extension cords in wet conditions. You should always assume that all electrical wires are fully energized and maintain a safe clearance distance of at least 10 feet from overhead power lines. To manage all of these risks, sites use a process called a job hazard analysis, which you will often hear called a JAR. A JAR is a technique that focuses on specific job tasks as a way to identify hazards before they occur. It involves breaking a task down into its simple steps, identifying the dangers in each step, and then finding a safe way to do the work. Once a hazard is identified, safety professionals use a system called the hierarchy of controls to determine the best way to protect workers. The hierarchy of controls is a specific ranked order of safety measures, moving from the most effective methods to the least effective methods. Memorizing this specific order is absolutely crucial for passing your certification exam. The first and most effective step in the hierarchy is elimination, which means physically removing the hazard entirely from the workplace. If elimination is not possible, the next step is substitution, which involves replacing the hazard with something less dangerous. For example, replacing a highly toxic cleaning chemical with a safe, water-based soap is a perfect example of substitution. If you cannot eliminate or substitute the hazard, you move down to the third level, which involves using engineering controls. Engineering controls are physical changes to the work area that isolate people from the hazard without relying on worker behavior. Installing physical guardrails around an edge, or putting safety guards on power saws, are classic examples of engineering controls. The fourth level of the hierarchy uses administrative controls, which change the way people work through rules and policies. Instead of physically changing the environment, you change the schedule or the procedures. Rotating workers in and out of a hot environment to prevent heat stroke is an administrative control because it manages exposure time rather than removing the heat itself. The very last and least effective level in the hierarchy of controls is personal protective equipment, often called PPE. Items like hard hats, safety glasses, and steel-toed boots belong in this category because they only protect you after the hazard has already reached your body. PPE is only used when all other higher-level controls fail to completely remove the dangers from the site. Before we finish this section, you need to understand the difference between a competent person and a qualified person on a job site. A competent person is someone capable of identifying hazards and has the direct authority from the employer to take prompt corrective measures to stop work. A qualified person, on the other hand, is someone who has a recognized degree, certificate, or extensive professional standing in a specific technical field. Congratulations on completing this first section and taking a huge step toward passing your exam. You should now go and complete the attached practice test to immediately apply what you have just learned. Answering practice questions is the single best way to improve your memory retention and test your exam readiness. The practice test is included right here with this lesson, so take a few minutes to actively engage with it now. Keep up this excellent momentum, and I will see you in the next section where we will master fall prevention. Welcome to the second section of your Site Safety Training Exam Preparation course. In this lesson, you will learn the critical differences between fall prevention and fall protection systems, alongside how to properly use life-saving equipment. Understanding these concepts is absolutely essential because falls are the leading cause of fatalities in construction, meaning this topic will be heavily tested on your exam. I am very excited to share this life-saving information with you today. Let us get started and prepare you to safely handle heights on any job site. Before we look at specific safety gear, you must understand the fundamental difference between fall prevention and fall protection. Fall prevention involves physical barriers that stop you from falling over an edge in the first place. Fall protection, on the other hand, involves the specialized gear that safely catches you after a fall has already started. Remember our golden rule from the previous lesson, which states that OSHA requires fall protection when you are working at heights of 6 feet or greater on a construction site. The most common and effective method of fall prevention is the use of standard guardrail systems. A standard guardrail is a strong physical barrier placed along unprotected edges, balconies, and rooftops to keep workers from stepping off into empty space. For your certification exam, you must memorize that the top rail of a standard guardrail must be exactly 42 inches high, plus or minus 3 inches, and must be able to withstand 200 pounds of downward or outward force. Directly below the top rail, a standard guardrail system must also include a secure midrail. The midrail is installed exactly halfway between the top edge of the guardrail and the walking surface, placing it at roughly 21 inches high. The primary purpose of the midrail is to prevent a slipping or sliding worker from falling through the middle space, and it must be strong enough to withstand at least 150 pounds of force. To completely finish a guardrail system and protect the workers walking below you, you must install toe boards along the bottom edge. Toe boards are small wooden or metal barriers that prevent tools, construction materials, and debris from being kicked over the edge and striking someone on a lower level. A standard toe board must be at least 3½ inches tall and withstand 50 pounds of outward force, which is a specific measurement that frequently appears on the exam. Another critical fall prevention method involves properly securing open floor holes on your job site. OSHA strictly defines a hole as a gap or void measuring 2 inches or more in its least dimension in a floor, roof, or other walking surface. All of these dangerous floor holes must be covered with rigid materials that are strong enough to easily support at least twice the weight of employees, heavy equipment, and materials that may cross over them. Simply placing a loose piece of plywood over a hole is incredibly dangerous and does not meet safety standards. Every hole cover must be physically fastened or secured down to prevent accidental displacement by strong winds, heavy equipment, or workers walking by. Furthermore, the cover must be clearly marked with the bright, highly visible word hole or cover to loudly warn everyone in the area about the hidden danger below. When physical barriers like guardrails cannot be used, workers must transition to relying on a personal fall arrest system, commonly referred to as a PFAS. This system is a form of fall protection designed to safely stop a worker who is already in the middle of a downward plunge. A complete fall arrest system always consists of 3 main components, known universally as the ABCs of fall protection, which stand for anchorage, body wear, and connecting devices. The letter A in the ABCs stands for anchorage, which is the totally secure structural point where you tie off your entire fall arrest system. Because this is the absolute foundation of your safety, the anchorage point must be incredibly robust and immovable. By federal law, a fall arrest anchorage point must be capable of supporting at least 5,000 pounds of force per attached employee, or it must be specifically designed and installed under the supervision of a qualified professional. The letter B stands for body wear, which in the modern construction industry always means a full body harness. A full body harness is a series of strong straps that distributes the extreme, violent stopping forces of a fall across your upper thighs, pelvis, chest, and shoulders. OSHA strictly prohibits the use of simple waist belts for fall arrest because they can cause severe spine and internal organ injuries when a falling worker stops suddenly. For a full body harness to save your life properly, it must be worn tightly and adjusted correctly to fit your exact body shape. The single most important feature on the harness is the back D-ring, which is the heavy metal loop where you will attach your lifeline. When you put on your harness, you must adjust all the chest and leg straps so that the back D-ring sits exactly in the center of your back, right between your shoulder blades. The letter C represents connecting devices, which are the specialized lifelines or lanyards that link your body harness directly to your chosen anchorage point. A standard shock-absorbing lanyard is a specific type of strap that contains a tightly woven deceleration device built into the fabric. This shock absorber violently tears open during a fall, which gently slows you down and greatly reduces the physical forces placed on your body when you reach the end of the rope. Another highly popular connecting device is a self-retracting lifeline, which is often called a yo-yo by construction workers. This heavy mechanical device works exactly like a car seatbelt, feeding line out smoothly as you walk around and locking up instantly if you suddenly yank or fall. Self-retracting lifelines are excellent safety tools because they eliminate excess slack in your line, meaning you will fall a much shorter distance before the internal braking system catches you. A major mathematical concept you will face on the certification exam is calculating total fall clearance distance. Fall clearance is the absolute minimum vertical distance required between your anchorage point and the lower level to ensure you do not hit the ground before your equipment fully stops you. To find this total safe distance, you must add up the length of your lanyard, the tearing distance of your shock absorber, your physical height, and a mandatory safety factor. Let us break down a standard fall clearance calculation step by step so you are perfectly prepared for the test. If you have a 6-foot lanyard, you must add 3.5 feet for the shock absorber tearing open, plus 6 feet for the worker's height, and a required safety margin of at least 3 feet. Adding these exact numbers together means you need a minimum of 18.5 feet of completely clear space below your anchor point to use a standard 6-foot lanyard safely. When choosing where to tie off, you must also carefully consider the dangerous pendulum effect known in the industry as a swing fall. A swing fall happens when your anchor point is not directly over your head, causing you to swing violently sideways like a pendulum if you slip off the edge of the roof. To prevent crashing into brick walls or adjacent steel structures during a swing fall, you should always try to anchor directly above your current working position. Even after a fall arrest system safely catches a falling worker, they immediately face a new, life-threatening emergency called suspension trauma. When you hang limply in a harness for too long, the tight leg straps cut off blood circulation to your lower body, which can cause fainting or even sudden death within minutes. Because of this extreme time-sensitive danger, every job site must have a written rescue plan to retrieve fallen workers as quickly as humanly possible. You are the first and most important line of defense when it comes to fall protection gear maintenance and safety. Every single time you prepare to put on a harness or use a lanyard, you must perform a thorough visual inspection of the equipment. You should look closely for fabric fraying, tiny cuts, burn marks, chemical damage, and rusted metal hardware, and you must immediately throw away any gear that shows signs of excessive wear. There is an absolute, non-negotiable rule regarding fall protection equipment that has actually caught a falling worker in real life. Once a harness, lanyard, or lifeline has been subjected to the extreme physical forces of a real fall, it must be immediately and permanently removed from active service. This safety gear cannot be repaired, stitched, or reused under any circumstances, and the certification exam will certainly test your knowledge of this strict equipment removal policy. Congratulations on successfully completing this critical section focusing on fall prevention and protection systems. I highly encourage you to complete the attached practice test right now while this detailed information is still fresh in your mind. Answering practice questions about guardrails and fall clearance dramatically improves your long-term retention and overall exam readiness. Please remember that the practice test is included right here with this lesson. Embrace this opportunity for active learning, keep up your excellent momentum, and I will see you in the next section where we will explore scaffold safety. Welcome to the third section of your Site Safety Training Exam Preparation course. In this lesson, we will focus on the specific rules and regulations surrounding scaffold safety and the construction of supported scaffolds. Learning how to work safely on and around these temporary structures is incredibly important because scaffolding accidents are a major cause of severe construction site injuries. I am eager to guide you through these essential concepts, so let us get ready to elevate your safety knowledge and master this portion of the exam. A scaffold is a temporary elevated platform used to support workers, materials, or both during construction and repair projects. Understanding how these structures are safely built and maintained is a massive part of your certification exam. There are many different types of scaffolds, but supported scaffolds, which consist of one or more platforms supported by rigid load-bearing members like metal poles or frames, are the most common ones you will encounter on a standard job site. The most important figure when dealing with scaffolds on any job site is the competent person. OSHA requires that all scaffolds be erected, moved, dismantled, or significantly altered only under the direct supervision of a competent person. For your exam, remember that this specific person must have the specialized training and authority to identify dangerous structural conditions and take immediate action to correct them. Regular visual inspections are critical for preventing scaffold collapses and protecting the lives of workers. The competent person is legally required to visually inspect the entire scaffold and its various components for visible defects before each work shift begins. If any part of the scaffold is found to be damaged, weakened, or missing, the entire structure must be completely tagged out of service until it is fully repaired or replaced. Understanding scaffold weight capacity is a very common topic on the certification test that you must memorize. Every scaffold and its individual components must be capable of supporting, without failure, its own weight and at least 4 times the maximum intended load applied to it. This 4-to-1 safety factor ensures that the structure remains completely stable even if extra heavy materials are temporarily placed on the platform during the workday. The wooden planks that create the actual walking surface of the scaffold have very strict safety manufacturing rules. Scaffold planks must be manufactured specifically for scaffolding use and graded as scaffold-grade lumber to ensure maximum strength and reliability. Standard construction wood from a local hardware store is never acceptable because it simply cannot handle the extreme physical stress required for safe elevated work. When workers are assembling the platform, they must place the wooden planks as close together as possible. The space between adjacent planks, and the space between the platform and the metal uprights, must be no wider than 1 inch. This strict 1-inch measurement prevents small tools, heavy bolts, or construction debris from falling through the gaps and striking workers passing by down below. Scaffold planks must either perfectly abut against each other at their ends or overlap each other significantly for structural support. If the planks overlap rather than sit flush, the overlap must occur directly over a sturdy metal support point and must be at least 12 inches long. This 12-inch overlap rule prevents the wooden planks from violently tipping upward like a seesaw if a heavy worker steps near the edge. The ends of the scaffold planks must extend past the final support point, but not by too much or too little. The standard rule is that the plank must extend over the end support by at least 6 inches, but no more than 12 inches. If a plank extends too far past the support, it creates a dangerous cantilever effect that will easily break or tip if someone accidentally stands on the extreme end. A scaffold is only as strong as the foundation it rests upon, making solid footing absolutely essential for safety. Supported scaffolds with frame legs must sit on heavy base plates and sturdy mud sills, which distribute the massive weight of the structure over a much larger area of ground. You must never use unstable objects like concrete blocks, loose bricks, or scrap lumber to level a scaffold on uneven dirt. As scaffolds grow taller, they become increasingly unstable and highly prone to tipping over in high winds. To prevent this disaster, scaffolds must be physically tied, guyed, or braced to the solid structural wall of the adjacent building. The general rule tested on the exam requires tying the scaffold directly to the structure once its height reaches 4 times its minimum base dimension. Workers must have a safe and secure way to access the scaffold platforms without resorting to dangerous climbing habits. Employers must provide proper access, such as attachable ladders, stair towers, or direct access from another building, whenever the scaffold platform is more than 2 feet above or below a point of access. Climbing the diagonal cross braces of a scaffold frame to reach the top is completely illegal and extremely dangerous. Fall protection on scaffolds is slightly different than the standard 6-foot rule used elsewhere in the construction industry. On scaffolding, OSHA mandates that workers must be protected from falling when they are working at a height of 10 feet or more above a lower level. This 10-foot threshold for scaffolding is a very common trick question on the exam, so be sure to memorize it carefully to avoid losing easy points. Just like standard roofs, the preferred method of fall protection on a scaffold platform is a standard guardrail system. These scaffold guardrails must include a top rail installed between 38 and 45 inches high, a secure midrail, and protective toe boards along the walking surface. The competent person is completely responsible for ensuring these rails are firmly attached before anyone begins their morning shift. In some specific situations, the diagonal cross braces of a supported scaffold can legally substitute for parts of a standard guardrail system. If the cross point of the brace falls between 20 and 30 inches above the platform, it can serve as a midrail. If the cross point falls between 38 and 48 inches above the platform, it can serve as a top rail, but a cross brace can never serve as both rails at the same time. Severe weather conditions dramatically increase the physical dangers of working on temporary elevated structures. Workers are strictly prohibited from working on scaffolds during strong storms or high winds unless the competent person has determined it is completely safe to do so. Additionally, all slippery ice, heavy snow, and wet mud must be entirely cleared from the wooden planks before work can legally begin. Workers on the ground constantly need protection from objects falling off the scaffold platforms located directly above them. Employers must require hard hats for everyone near the scaffold base and install physical protections like toe boards or specialized debris nets along the edge of the elevated platforms. If the overhead hazard is particularly severe, the area below the scaffold must be barricaded to physically prevent anyone from walking underneath. Scaffolds are typically made of highly conductive metal, making overhead power lines a massive, life-threatening hazard on the job site. Scaffolds must never be erected, moved, or altered closer than 10 feet to active, uninsulated power lines. Maintaining this minimum 10-foot electrical clearance zone prevents accidental electrical arcs and catastrophic electrocutions, making it a critical number for your safety and your certification exam. Because scaffolds present so many unique and deadly hazards, specialized training is a legal requirement for everyone involved. All employees who work on a scaffold must be formally trained by a qualified person to recognize the specific dangers associated with their daily tasks, including fall hazards and electrical risks. If an employer changes the type of scaffold being used, the workers must be completely retrained before using the new equipment. Congratulations on successfully finishing this third section and mastering the critical rules of scaffold safety and construction. You should now go and complete the attached practice test to see how well you absorbed these specific height, weight, and distance requirements. Answering practice questions directly improves your memory retention and ensures you are totally ready for the actual certification exam. Keep in mind that the practice test is included right here with this lesson to help you succeed. Please encourage your active learning habits, keep up your excellent focus, and I will naturally transition you to the next section where we will tackle hazard communication. Welcome to the fourth section of your Site Safety Training Exam Preparation course. In this lesson, we will uncover the critical rules of hazard communication and how to properly select and use personal protective equipment. Learning this material is incredibly important because chemical exposures and physical injuries can be just as deadly as falls, and these topics are guaranteed to appear on your certification test. I am excited to help you decode these safety standards so you can protect yourself and your coworkers. Let us dive in and build your expertise on workplace hazards. The Hazard Communication Standard, often called the Worker Right to Know Law, is one of the most important OSHA regulations you will study. This standard guarantees that you have the absolute legal right to know exactly what hazardous chemicals you are working with and how to protect yourself from them. Employers are legally required to provide comprehensive training on every single chemical hazard present on your specific job site before you ever begin working. To make chemical dangers universally understood, OSHA adopted the globally harmonized system of classification and labeling of chemicals, simply known as GHS. This worldwide system ensures that chemical labels and safety information look exactly the same no matter where a product was manufactured. Because of this system, you can quickly identify chemical dangers using standardized pictograms, warning words, and clear hazard statements. A major part of this global system, and a frequent topic on your exam, is the use of standardized pictograms on chemical containers. Pictograms are distinct graphic symbols framed by a red diamond shape that visually represent the specific physical or health hazard of a chemical. For example, a picture of a flame over a circle indicates that a chemical is an oxidizer, while a picture of a skull and crossbones clearly warns of severe and immediate toxicity. In addition to pictures, every chemical label must feature a specific signal word to immediately alert you to the severity of the danger. There are only two authorized signal words used in this entire system, which are danger and warning. The word danger is used for the most severe hazards, while the word warning is used for less severe, but still dangerous, chemical threats. The absolute backbone of hazard communication is the safety data sheet, universally referred to as an SDS. An SDS is a detailed, 16-section informational document created by the chemical manufacturer that explains everything you need to know about a specific hazardous substance. Employers must keep a complete, easily accessible binder or digital database of safety data sheets for every single chemical used on the job site. For your certification exam, you need to know that every safety data sheet follows the exact same strict 16-section format. This standardization means that if you need emergency first aid information, you will always find it immediately in Section 4, regardless of what chemical you are looking at. Similarly, if there is an accidental chemical spill, you will always turn straight to Section 6 to find the exact cleanup instructions. A common safety violation occurs when workers transfer a chemical from its original manufacturer bottle into a smaller secondary container, like a spray bottle. Whenever you move a hazardous chemical into a new container, you must ensure the new bottle is immediately and properly labeled with the chemical name and its primary hazards. The only exception to this strict labeling rule is if you pour the chemical solely for your own immediate personal use during that exact same work shift. While hazard communication helps you understand chemical dangers, personal protective equipment, or PPE, is your final physical barrier against workplace injuries. Remember from our earlier discussion on the hierarchy of controls that PPE is always the last line of defense used when hazards cannot be completely eliminated. Your employer is legally required to pay for and provide almost all forms of required PPE, with a few specific exceptions like everyday work boots and standard prescription safety glasses. Eye and face protection is mandatory whenever workers are exposed to flying particles, molten metal, liquid chemicals, acids, or potentially dangerous light radiation. Standard safety glasses must have side shields attached to protect your eyes from debris flying in from the periphery. For tasks involving splashing chemicals or heavy dust, you must step up your protection and wear tight-fitting chemical goggles instead of standard open glasses. When you are performing high-risk tasks like grinding metal, cutting concrete, or handling highly corrosive liquids, simple goggles are not enough. In these situations, you must wear a full plastic face shield to protect your entire face, cheeks, and neck from severe damage. However, a crucial rule for your exam is that a face shield is never a substitute for primary eye protection, meaning you must always wear safety glasses or goggles underneath the face shield. Head protection is required anytime there is a potential for objects falling from above, bumps to the head from fixed objects, or accidental contact with electrical hazards. Construction hard hats are divided into specific classes based on their electrical resistance, which is a detail frequently tested on exams. Class G hard hats provide general protection and low voltage resistance, while Class E hard hats provide exceptional electrical protection against extremely high voltage. You must inspect your hard hat daily for cracks, dents, and heavy sun damage before you put it on your head. The internal suspension system inside the hard hat is what actually absorbs the impact of a falling object, keeping the hard plastic shell safely away from your skull. You should never paint your hard hat or drill holes into it, because these alterations degrade the structural integrity of the plastic and will cause the hat to fail during a real impact. Proper foot protection is required when working in areas where there is a danger of foot injuries due to falling or rolling objects, or objects piercing the sole. Steel-toed or composite-toed work boots are standard issue on construction sites to prevent crushed toes from dropped heavy materials. If you are walking on demolition sites with exposed nails, you must ensure your boots have thick puncture-resistant soles to prevent severe foot injuries. Construction sites are incredibly loud, and prolonged exposure to high noise levels will cause permanent and irreversible hearing loss. OSHA requires employers to implement a hearing conservation program whenever noise exposures equal or exceed 85 decibels over an 8-hour shift. If administrative controls cannot lower the noise, workers must be provided with appropriate hearing protection, such as expanding foam earplugs or heavy-duty earmuffs. Respiratory protection is one of the most complex and strictly regulated areas of personal protective equipment. When workers are exposed to harmful dusts, fogs, fumes, mists, gases, or vapors, employers must provide appropriate respirators to prevent long-term lung diseases. A common hazard requiring respiratory protection on construction sites is crystalline silica dust, which is a deadly powder created when cutting bricks, concrete, or stone. Before you are ever allowed to wear a tight-fitting respirator on a job site, you must pass a medical evaluation to ensure your heart and lungs are healthy enough to handle the breathing resistance. After medical clearance, you must undergo a strict physical fit test to prove that the specific mask size and model forms a perfect, airtight seal against your unique face shape. This fit testing must be repeated annually, and you cannot have any facial hair that interferes with the sealing edge of the respirator. Hand injuries are incredibly common in construction, making proper glove selection a vital daily task. You must choose the specific type of glove that matches the exact hazard you are facing, because no single glove protects against everything. Heavy leather gloves are excellent for preventing cuts when handling sharp metal, while thick rubber gloves are absolutely necessary when working with corrosive chemical solvents. Employers cannot simply hand you a box of safety gear and tell you to get to work. By law, employers must train every single worker who is required to use personal protective equipment. You must be taught exactly when PPE is necessary, what specific gear is required, how to properly put it on, how to adjust it, the physical limitations of the gear, and how to safely dispose of it when it wears out. Congratulations on completing this fourth section and taking another major step toward earning your certification. You should now go and complete the attached practice test to reinforce your knowledge of chemical labels and safety gear. Explaining these concepts through practice questions drastically improves your memory retention and overall exam readiness. Please remember that the practice test is included directly with this lesson for your convenience. Keep up your active learning habits, end this session positively, and I will naturally transition you to the next section where we will explore excavation and heavy machinery operations. Welcome to the fifth section of your Site Safety Training Exam Preparation course. In this lesson, we will explore the massive physical forces involved in excavation, trenching, and operating heavy construction machinery. Learning this material is critical because moving thousands of pounds of earth and steel presents some of the most sudden and catastrophic dangers on any job site. I am thrilled to help you master these concepts, so let us dig right in and prepare you for the hardest questions on your exam. An excavation is broadly defined as any man-made cut, cavity, trench, or depression in the Earth's surface formed by earth removal. A trench is defined more specifically as a narrow underground excavation that is deeper than it is wide, but never wider than 15 feet. Understanding this exact definition is important for your exam, because trenches present much higher risks of sudden cave-ins compared to wide, open excavations. Just like with scaffolding, excavation work legally requires the presence of a competent person on the job site at all times. This individual must possess the specific knowledge to identify dangerous soil conditions, predict potential cave-ins, and authorize immediate corrective measures. The competent person must conduct daily visual and manual tests of the trench before any worker is allowed to step foot inside the hole. OSHA strictly classifies soil into specific categories based on its stability and structural strength. The four main classifications you must know are stable rock, Type A, Type B, and Type C soil. The certification exam will certainly test your ability to match the correct soil type with its specific physical characteristics and required safety measures. Stable rock is solid mineral matter that can be excavated with vertical sides and remain completely intact while exposed. Type A soil is the most stable form of standard dirt, typically consisting of heavy clay that holds its shape very well. You can easily identify Type A soil because it is highly cohesive, meaning the dirt particles naturally stick tightly together when you squeeze them in your hand. Type B soil is moderately stable and usually consists of silt, sandy loam, or medium clay. This dirt is less cohesive than Type A and is far more prone to crumbling or shifting under physical pressure. If a trench has previously been disturbed or dug up in the past, OSHA automatically downgrades the soil to Type B because the natural compaction of the earth has been permanently broken. Type C soil is the least stable and most dangerous soil classification you will encounter in the field. It consists of loose granular materials like gravel, pure sand, or submerged soil with a very high water content. Because this dirt offers almost zero structural stability, OSHA requires you to treat all unidentified soil as Type C until a competent person officially proves otherwise. The most terrifying danger of trenching is a sudden cave-in, which can bury a worker under thousands of pounds of suffocating dirt in mere seconds. OSHA mandates that all workers in trenches measuring 5 feet or deeper must be protected by a specific cave-in protection system. However, if a competent person spots signs of a potential collapse, protective systems must be used even if the trench is completely shallow. The first method of cave-in protection is called sloping, which involves cutting back the trench walls at a specific safe angle. This precise angle inclines away from the excavation, naturally preventing the dirt from sliding straight down into the workspace. The required angle of the slope depends entirely on the soil classification, with looser Type C soil requiring a much wider and flatter slope than solid Type A clay. When a job site does not have enough physical space to cut wide earthen slopes, workers must use a shoring system. Shoring involves installing a strong physical framework of aluminum hydraulic cylinders and wooden panels directly against the trench walls. This rigid skeleton physically pushes back against the dirt, actively holding the heavy earth in place while the workers operate safely inside. The third protective method is shielding, which most commonly involves dropping a heavy steel trench box directly into the excavation. Unlike shoring, a trench box does not push back against the dirt to prevent a collapse from occurring. Instead, it serves as a hyper-strong protective shell that simply absorbs the crushing force of a cave-in, keeping the workers completely safe inside the steel walls. Getting trapped inside a trench is deadly, so OSHA has strict rules for safely entering and exiting the excavation. Any trench that is 4 feet or deeper must have a safe means of egress, such as a secure ladder, a stairway, or a safe earthen ramp. Furthermore, a worker must never have to travel more than 25 horizontal feet inside the trench to quickly reach one of these safe exits. When you dig dirt out of a hole, the removed earth is called the spoil pile, and it presents a massive crushing hazard of its own. OSHA requires that all excavated dirt, heavy equipment, and construction materials must be kept at least 2 feet away from the edge of the trench. This mandatory 2-foot clearance zone prevents heavy rocks from rolling off the pile and striking the workers trapped down below. Excavations are heavily intertwined with the use of massive construction machinery, bringing us to the second half of this critical lesson. Operating heavy equipment like excavators, bulldozers, and loaders creates extreme struck-by and crushing hazards across the entire job site. Workers on the ground must always maintain constant visual eye contact with the equipment operator to ensure they're never accidentally run over in a blind spot. Because construction vehicles have massive blind spots, especially when moving in reverse, strict warning systems are legally required. Every piece of heavy machinery with an obstructed rear view must have an automatic backup alarm that sounds loudly whenever the vehicle shifts into reverse. If the alarm is broken, the vehicle absolutely cannot move backward unless a human spotter stands safely to the side and physically guides the driver. Cranes are the towering giants of heavy machinery, capable of moving massive loads over incredible distances. The biggest hazard associated with cranes is accidentally touching the boom or the steel hoist line to overhead electrical power lines. To prevent catastrophic electrocution, crane operators must maintain a minimum clearance distance of at least 10 feet from standard power lines at all times. The heavy steel chains, thick nylon straps, and metal shackles used to connect a load to a crane are collectively called rigging equipment. A qualified rigger must carefully inspect every piece of rigging before each work shift to ensure there are no weak links or frayed fibers. You must absolutely never stand, walk, or work underneath a suspended load, because rigging failures happen instantly and with deadly consequences. Heavy machines like excavators and cranes constantly rotate their massive counterweights in a circular motion known as the swing radius. This heavy rear section can easily crush a worker against a nearby wall if they enter the danger zone without warning. Employers must physically barricade the swing radius of rotating equipment to forcefully prevent workers from accidentally walking into this deadly pinch point. Most earth-moving equipment is equipped with a heavy metal roll cage called a rollover protective structure, frequently abbreviated as ROPS. This strong steel frame is designed to prevent the driver from being crushed if the heavy machine accidentally tips over on a steep, unstable hill. However, a roll cage only works if the operator stays inside the protective shell, making the use of seatbelts absolutely mandatory at all times. Congratulations on completing this 5th section and expanding your knowledge of trenching and heavy machinery safety. You should now go and complete the attached practice test to see how well you remember those exact soil types and clearance distances. Exploring these practice questions guarantees you will improve your long-term retention and overall exam readiness. Please remember that the practice test is included securely with this lesson for your immediate use. Keep pushing forward with this active learning, maintain your positive energy, and I will naturally transition you to the final section covering site safety plans. Welcome to the 6th and final section of your Site Safety Training Exam Preparation course. In this lesson, we will explore the critical administrative frameworks that keep construction sites organized, specifically focusing on site safety plans and emergency response procedures. Learning this material is incredibly important because proper planning prevents chaotic situations from turning into fatal disasters, and these management concepts are heavily tested on your exam. I am thrilled to help you master this final piece of the puzzle, so let us dive in and prepare you to confidently manage site-wide safety protocols. A comprehensive site safety plan is a highly detailed written document that outlines exactly how a specific construction project will protect its workers and the public. You must understand for your exam that safety plans cannot be generic, copy and paste documents from a previous job. Every single site safety plan must be entirely site-specific, addressing the unique hazards, layout, and geographical challenges of that exact construction location. On large-scale construction projects, the execution of this plan is overseen by a designated site safety manager or site safety coordinator. These licensed professionals act as the central authority for all safety-related decisions and are legally required to be present on the job site during all major construction activities. Their primary job is to constantly walk the site, enforce the safety plan, and immediately correct any hazardous conditions they discover in the field. One of the most important administrative duties of a site safety manager is maintaining the daily logbook. The daily log is a strict legal record that documents all safety inspections, safety meetings, accidents, and severe weather conditions that occurred during the shift. Because this is an official legal document, it must be kept on the job site at all times and made immediately available to OSHA inspectors upon their arrival. To keep all workers informed of daily hazards, sites utilize short safety meetings commonly known as toolbox talks. These are brief, highly focused training sessions held right on the job site before the morning shift begins. Employers must always collect the signatures of every worker who attends a toolbox talk, because these attendance sheets serve as legal proof that the required hazard training actually took place. Even with perfect planning, unexpected crises can still occur, which is why every construction site must have a written emergency action plan. An emergency action plan, often called an EAP, is a formal document detailing the exact actions employers and employees must take to ensure widespread safety during an emergency. This plan covers chaotic events like massive fires, sudden building collapses, severe chemical spills, and extreme weather emergencies. A massive part of the emergency action plan focuses on clear and rapid evacuation procedures. The plan must clearly define the primary and secondary escape routes from every location on the construction site, ensuring workers never become trapped by a sudden emergency. These evacuation routes must be kept completely clear of construction debris, heavy equipment, and building materials at all hours of the day. Once workers evacuate a dangerous building, they must immediately report to a predetermined safe area known as a muster point or assembly area. Gathering at this specific location allows supervisors to quickly conduct an accurate head count of all their employees. Having a perfect head count is an absolute lifesaver, because it prevents emergency rescue teams from risking their own lives searching a burning building for a worker who is already safely outside. Preventing fires from starting in the first place is heavily tested on the certification exam, especially regarding hot work. Hot work includes any construction activity that produces sparks, open flames, or extreme heat, such as welding, cutting, or brazing metal. Before hot work can begin, a supervisor must issue a specific hot work permit verifying that all flammable materials have been safely removed from the immediate work area. After a welding or cutting task is completed, a dedicated fire watch must be maintained in the area. A fire watch is a specifically assigned worker holding a fire extinguisher whose only job is to constantly watch for smoldering sparks. The exam frequently asks about timeframes, and you must know that a fire watch is legally required to remain at the location for a minimum of 30 minutes after the hot work has officially ended. When dealing with early-stage fires, workers are trained to use portable fire extinguishers utilizing a highly tested acronym called PASS. The PASS method stands for pull the pin, aim the nozzle low at the base of the fire, squeeze the handle to release the chemical, and sweep the nozzle from side to side. Memorizing this exact four-step process is incredibly important for passing your exam and stopping small fires before they grow out of control. Medical emergencies are another critical component of the site response plan. OSHA requires that if a hospital, clinic, or infirmary is not in close proximity to the workplace, the employer must ensure there are workers on site who are fully trained to provide first aid and CPR. Close proximity is generally interpreted by OSHA as a rapid response time of 3 to 4 minutes for life-threatening injuries. When providing first aid, workers must always protect themselves from bloodborne pathogens, which are infectious diseases transmitted through human blood. The golden rule for handling blood is called universal precautions, which means you must treat all human blood and bodily fluids as if they are actively infected with a deadly disease. First responders must always wear medical gloves and safety glasses to prevent cross-contamination while helping an injured coworker. If a severe accident occurs, the employer faces strict legal deadlines for reporting the incident directly to OSHA, and you must memorize these exact timeframes. If an accident results in a worker fatality, the employer must officially report the tragic death to OSHA within 8 hours of finding out about it. For severe but non-fatal injuries, the reporting window is slightly longer but just as strict. If a worker suffers an inpatient hospitalization, an amputation, or the physical loss of an eye, the employer must report the severe injury to OSHA within 24 hours. Failing to meet these strict 8-hour and 24-hour reporting deadlines will result in massive financial penalties for the construction company. Site security is another major responsibility that prevents injuries to the general public. Construction sites are full of dangerous equipment and deep trenches that look incredibly fun to neighborhood children, a concept legally known as an attractive nuisance. To prevent tragic accidents after hours, employers must install high perimeter fences, lock up all heavy machinery, and post clear warning signs around the entire site boundary. Weather emergencies also trigger specific safety protocols within the site plan. If a lightning storm approaches the site, all crane operations must cease immediately, and workers must evacuate elevated platforms and metal structures. High winds also require swift action to tie down loose building materials, secure tall scaffolds, and prevent lightweight debris from blowing off the site and striking pedestrians below. A truly excellent safety plan relies on a workplace culture that embraces stop work authority. Stop work authority is a powerful policy granting every single worker on the site, regardless of their job title, the absolute right and obligation to halt a work task if they discover an imminent danger. Empowering beginners to speak up without fear of being fired or punished is the ultimate administrative control for preventing fatal accidents. As you prepare to take your certification exam, remember that all these rules, plans, and regulations share one singular goal. Whether it is a daily logbook, an emergency headcount, or a hot work permit, the true objective is always to ensure every worker goes home safely to their family at the end of the day. Keeping this protective, life-saving mindset will help you easily guess the correct answer on complex scenario-based exam questions. Congratulations on completing this section and finishing all the core instructional material for your exam prep course. You should now go and complete the attached practice test to solidify your grasp on emergency action plans and safety management. Exposing yourself to practice questions dramatically improves your memory retention and verifies your true exam readiness. Be sure to use the practice test included right here with this lesson. Please continue your active learning, maintain your positive momentum, and I will naturally transition you to the next section where you can tackle your final comprehensive mock exam.